Now, so you need to know the 6 physical changes. What are the 6 physical changes? The 6 main physical changes. You don't know, you don't remember, you don't care. Give me some hints here, guys. Should I push on? Should I not have a review? What do you want to do? You're going to give them to me or what? Those are physical properties. No, that's a state of matter. Melting, freezing, right? Condensation, evaporation, deposition, sublimation. Yes? Yes? Okay. So, you have to know physical properties. You have to know the difference between extensive and intensive. Okay? Extensive or what? What are some extensive ones? It's not in the book. I added it. It's a weakness in the book. What are extensive physical properties? There are 2 types of physical properties. There are physical properties that will not be characteristic of a particular substance. And then there are physical properties that are characteristic of a particular substance. For instance, mass and volume are called extensive. Mass, volume, what else? Anyone? I'm trying to explain to you what extensive means. I just said what extensive means. I said that there are 2 types of physical properties. There are properties that will not define matter as being a particular type of matter, that are not characteristic of a particular substance, such as volume, mass. What else?
Viscosity.
No, density is not extensive. Density, water has a density of 1. Mercury of 1 gram per cubic centimeter. Mercury is 13.6. I mean, those densities will help verify the identity of a substance. Those are intensive physical properties. Give me another extensive physical property. I'm giving you 2, volume and mass. Give me another one. What is it?
Viscosity.
No. Look. Do you think viscosity is, yes, temperature dependent, but don't you think viscosity is a type of property that would be specific to a particular substance? Yeah. So would that be extensive or intensive?
Intensive.
It would be what?
Intensive.
That would be intensive, right? What I'm asking, Nadeem, listen to my words carefully. I am saying to you, 2 extensive physical properties are mass and volume. I'm asking you for a 3rd one. What would a 3rd one be? Give me another one.
Density?
Excuse me?
Density is intensive.
Is density an extensive physical property? No.
Explains.
It's an intensive physical property.
It explains in that.
Brugman, are you not paying attention? You're not participating today? You don't feel like it? What's the length of that piece of paper? Give me approximate length. Give me approximate in centimeters.
Density. Sir,
I'm going to guess
8 inches.
28. I don't know if that's right. You have a ruler? Anybody have a long ruler? 30 centimeter ruler? No? Nobody has a ruler. Yeah, go get one. Okay, so if I take this and I rip it like this, do I change the length of that?
Yes.
Yeah, I change the length, right? Now, do I change the substance? I mean, are there other? We're talking about. I'm trying to get you to understand what extensive physical properties are. All right, that width was about 20 centimeters. Okay? Now it's 13.5. Now, is that length. Is that, you can sit right there. There's a spare seat right there. There you go, right there. Is that length characteristic of paper? Is it? So is length intensive or extensive? It's what? Yeah, it's extensive. So length, mass, volume, those are all extensive physical properties. Give me some characteristic, give me some intensive physical properties.
Hardness.
What is it?
Hardness.
Hardness. So, give me some more solubility. Give me some more. You said ductility. Give me another one. Density we have. Melting point, boiling point. Specific heat capacity. What is it? Well, I can't hear you.
Millimeter.
What did you say?
Millimeter.
Millimeter? Oh, malleability. Yes, malleability is one. Absolutely. What is it? Viscosity. Viscosity is one. Is color a characteristic physical property? Yeah, it could be. It could be. It could be. That could also be deceiving. You know, it could be deceiving on many holidays. I live in Vietnam and on Tet. You never know what the true color is of certain flowers they put out because they color them. You know, they artificially color the flowers. You have really no idea. You know, you have no idea. So it's difficult to tell. Things can be painted. But yes, you may not have ever seen this, but there's a very typical color. It's actually quite a beautiful color. Copper sulfate, copper 2 sulfate. Called copper 2 sulfate pentahydrate. Very beautiful blue, like almost a cyan blue or a royal blue. Very, very beautiful color. That's very indicative. If I had crystals, and they were that particular color, I would say that they could be copper 2 sulfate pentahydrate. If I heated them and it turned white, then what I did was I evaporated off the water, and that's definitely going to be that particular substance. Yeah. Okay. So color could be a characteristic physical property. What else? Anything else? Specific heat capacity could be a characteristic physical property.
What's the specific heat?
What is it?
What is the specific heat?
I can't hear you.
What is the specific heat capacity?
Specific heat capacity is how much heat a substance can hold. And a specific heat capacity is a number. For instance, water is 4.81 joules per gram degree Celsius.
What is 4.81?
4.81 joules. Joules is a measure of mechanical energy. You may know. It may make more sense if I said 1 calorie per gram degree Celsius. 1 calorie equals 4.18 joules. So if I said 1 calorie, that would make more sense to you possibly. You may never have heard of the word joule before. Joule is named after a scientist named Joule. His last name was Joule. So, and iron is 0.45 joules per gram degree Celsius. So if I measure the specific heat capacity and it turns out to be 0.45, that's joules per gram degree Celsius, meaning it takes 0.45 joules to raise the temperature of 1 gram of that substance 1 degree Celsius. Yes? So it takes 1 calorie to raise 1 gram of water 1 degree Celsius. See? Or 4.18. So it takes 10 times the amount of energy. So water has a higher capacity for heat. You've heard of hurricanes and storms and typhoons, and that's because water can contain so much energy And when you put enormous quantities of water in the upper atmosphere, clouds, not the upper atmosphere, the upper stratosphere, you have the upper troposphere, you have tremendous storms, tremendous, because of all that energy. What else? Let's see. You have to know the names and recognize the symbols for those elements on the periodic table. Yes? It was definitely 1 through 20. I think it was even 1 through, it was 1 through 20. I think it was even 1 through, was it 1 through 38? Do you have your periodic table with you? Anybody? You should bring all of your papers every class. Okay? So you're going to have to know the elements, names, and symbols on periodic table that I gave you. Not all of them. Okay? Not all of them. May I see your table, please? So you're going to have to look them up because I gave you the symbols. So if you look at your periodic table, you have hydrogen, helium, lithium, beryllium is number 4. And then we continue with boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. And then you want to go to scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So that's the first row of that middle transition elements. And then underneath that, just silver, cadmium, lutetium, gold, mercury, lawrencium, seaborgium, and maybe you may want to look up Seaborg, Glenn Seaborg, that's a good name to know. And then the first column, under potassium, rubidium, cesium, francium, strontium, barium, radium, lanthanum, actinium, uranium, plutonium, what else? All of the halogens. So underneath chlorine, you have bromine. That should be a BR. That's a misprint. That is a misprint. That's BR. Bromine. BR. You see under chlorine? Under chlorine is B. It should be BR, bromine, and then iodine, and then the noble gases are helium, neon, argon, krypton, xenon, and radon, and that's it. Okay, so you have to know those. What else? Let's see. You need to know the definitions of a solid liquid gas. All right, for instance, let's look at solid. Is a solid, is it a definite shape? Is a solid? Yes, it is. Is it a definite volume? Yes. Is it easily compressed? No. How about a liquid? Is a liquid a definite shape? No. Is it a definite volume? Absolutely. Is it easily compressed? No, a liquid is not easily compressed. Where do you get that it is? I don't understand that. Was that a dead guess or? Yeah, it was a complete guess. You tried to sound intelligent and you were wrong, but you could have been right? Okay, I understand. All right, let's see. Let me take this like this. Let's see. What about gas? Is gas definite shape? No. Definite volume? No. How about easily compressed? Who said no?
I didn't say.
You said no? You're wrong again. You're 0 for 2 there, big guy. Okay, so a gas is easily compressed. Okay, let's see. What else? I have some things on boiling. You have to be able to read a table with melting points and boiling points. Very straightforward. You have to know physical changes. Dissolving is a physical change. The 6 physical changes I showed you, those are the relative to change of state. What are the 4 states of matter? I know, I threw you off by saying 4. If I said 3, you'd know easily, right? But what's the 4th one? What are the 3 states of matter? What are they? What is it?
Solid liquid.
Solid, liquid, gas, and what's the 4th one? It's the main one. It's the biggest one. It's
The normal.
plasma. We talked about that, remember? All right, let's see. So you have to know what the elements are. You have to know what mixtures. What's a mixture? Mixture. What is it? More than one phase, right? So you have 2 things. You have 2 types of mixtures, don't you? You have 2 types of mixtures. You have homogeneous and you have heterogeneous. Right? Homogeneous, what's an example of a homogeneous mixture? General term. Just anything. What comes to your mind? One phase. No? Maybe I'll give you the test tomorrow. What a great idea. I think I'll do that. Excellent. Excellent. I'll have you come in. I'll get special permission to have you guys come to school. It's a regular school day for us. You certainly can come in. I could easily get permission by the end of the day. It would be no problem. So you want to participate or not? Okay, good. Just asking. So give me an example of a homogeneous mixture where you're mixing 2 things together and you're getting one phase. Salt water?
Yes.
Sugar water? Yeah, you get it? An alloy? Solid? Yes? Air? I mean, they're countless, aren't they? Yes or no? Give me an example of a heterogeneous mixture.
So what's it?
Heterogeneous mixture. 2 or more phases when you mix 2 things together. This laptop and the air. Did that laptop dissolve in the air? It did? Well, is it a mixture? It's not a mixture?
It's a mixture.
It's not a mixture? I'm stirring that around! You're telling me the laptop and the air, you don't know what that is. That's not a heterogeneous mixture? Of course it's a heterogeneous mixture. How about everything in this classroom that you can see in the air? Is that a heterogeneous mixture or a homogeneous mixture? It's heterogeneous. Yes or no? Absolutely. Sand and feathers. Is that homogeneous or heterogeneous? Heterogeneous. Yes or no? Easy? Man, you guys are half asleep. I want everybody to know it's like 8:15 in Dhaka, Bangladesh, and you guys look like poop. You guys look terrible. You're half asleep. You guys what time did you go to bed last night, Albie? 1 o'clock, 1:30, right? Yeah, okay. All right, excellent. All right, what about gasoline?
What is that? Oh, it is a homogeneous.
Gasoline is it an element, a compound? What is a compound? No,
It's a mixture. It's
We're
not.
both like, no, yell at me, I'm wrong. It's a mixture. We did this. It's a mixture of a bunch of different substances. It's a mixture of things like hexane, heptane, octane, nonane. It's a mixture of fraction of oil. You know, you have methane, which is one carbon, it's a gas. You have ethane, which is a gas. Propane is a gas at room temperature. Butane is a gas at room temperature. Then as I add carbons, pentane, hexane, now I'm getting into liquids. Very volatile liquids, yeah? Very volatile liquids. Then I'm getting, you've heard of octane? What's the octane rating of gasoline? There's a lot of octane in gasoline. Petrol, used for your car. So it's actually a mixture. So you're gonna have to read up on mixtures. Alternate, you're gonna have to look up the idea of mixtures and be able to distinguish between or and among mixture, substance, element, and compound. You're gonna have to know the difference. There's two kinds of mixtures, yes? Yeah, so you have to be able to know. Vinegar, what's vinegar?
Oh, yeah.
What's vinegar? Is vinegar a mixture? What is it?
Mixture.
It's a mixture of what two things? You know?
Water and something.
Water and, oh, I like that. Water and something else. No, that was good. That was actually quite good. I'll give you the old name. Acetic acid. Water and acetic acid. It's a dilute solution of water and acetic acid. Okay, you got to know the difference between physical change and chemical change. Give me a chemical change. Anybody? What is it? Burning. Good. I like that. Burning. What else? What else? What is it? I have no idea what you said. Could I have an interpretation, please? It's me. Your English is perfect. It's just your accent. My hearing is terrible. What did he say?
Combustion.
Combustion. Yes, combustion. Combustion is, yes, absolutely. We talked a lot about combustion, but we talked about corrosion in the chapter, but we kind of left out combustion, but we've already spoken about combustion quite a bit. Combustion is when you're doing what? What is combustion? When you add what? When you're burning something in the presence of oxygen, mostly like hydrocarbons, like gasoline or candles or, you can sit down please and stop goofing around. So you have candles, you have gasoline, you have oil, you have wood, yes? All right, now. So let me give you a great way of breaking something down to cause a chemical change. Okay, if you take something like water. Water breaks down into hydrogen and oxygen, right? So what I have to do in order to make that happen, because water by itself, pure H2O, does not conduct electricity. So I have to add a salt, and a very common salt that's used in this is called, that I've used in experiments with my students in other schools, sodium nitrate I've used, right? And you drive an electric current through. This is called electrolysis. It's called electrolysis. It'll be on your test. Okay. So, now another one would be, if I took a base, for instance, magnesium hydroxide. This is a whole series of experiments where I take a base is a metal hydroxide is a base. And this symbol means heat. And I heat, yeah? If I heat it, yeah, I get the metal oxide plus water. Okay? This is a base. Anything with hydroxide in it is a base. A metal oxide is called a base anhydride. They're called base anhydrides. Well, it's easy, a base, right? But any metal oxide is a base anhydride. And if you combine it with water, you get a corresponding base. Okay? We'll do this, I'll do this as a demo, actually. All right, now, I'll do the reverse of that. So these are, heat and electrolysis are ways of causing chemical change. Okay? A match, that's a flame. Can you have, if I add oxygen to gasoline, is that a physical change or a chemical change? If I add oxygen to gasoline, is that physical or chemical?
Chemical.
All right, let me ask you another question before you give me your final answer. If I add salt to water, is that physical or chemical?
Physical.
That's physical. So I'm actually dissolving oxygen into the gasoline. Yes?
Physical.
It's physical.
Yeah.
I didn't say I was igniting it. You can have, haven't you ever smelled gasoline?
Yes.
You've never smelled gasoline? God bless you. You've never smelled gasoline? You've never, what do you, ride horses to school or you've never been in a car? You've never seen a bus? You've never been on the streets? Ever?
Yes.
You've never,
I got it.
you've never smelled gasoline, petrol. Okay, I think you have. So you can dissolve oxygen into gasoline, and it's physical. It's not chemical. And so you got to be careful. If you add enough heat, then what happens? You get what? You get fire. Okay, fire. Okay. You get combustion. You get combustion. Yeah. So let's look at this again. You have reactants. Remember we talked about this. You have reactants, and you have this is a chemical change, and you get your products, right? Right? Remember? Let's say I have sodium plus water, right? And I take 25 grams of this plus 30 grams of this. What mass of products am I going to get? Can you figure it out? Do you have enough information?
46, 55.
Yeah, I'm going to get 55 grams of product. And what is that based on? This is a little bit of an addition. Yeah. This is called the conservation of mass, which means the reactants equals the product. The mass of the reactants equals the mass of the products. Easy? It's called the conservation of mass. What is the conservation of mass? In regular chemical reactions, as opposed to nuclear, in regular chemical reactions, the mass of the reactants must equal the mass of the products. Mass is conserved, always. Understood? Okay. Yeah. Okay, so what is a chemical what is a chemical property? What is it? What is it?
Characteristics of a substance which defines physical
Well,
properties defines
since this should be a review and you should be able to talk about it a little bit better, a chemical property is any property that is only obvious when a substance is in the presence of another substance.
Should be.
So instead of talking about a chemical property, okay,
Should get.
and we'll talk about chemical properties in a minute, but give me some signs that a chemical change has taken place. Give me some chemical changes. Okay, anything? Color change, is that what you said?
So its color change is also visible.
Color change? Color, yeah, if you paint it, now color change is pretty chemical. That's one of the classic signs. What else? You get bubbling, effervescence, bubbling or effervescence. Yes. What else? What is it? Heat transfer?
Energy
Is
transfer.
that energy transfer? So heat. So in other words, exo or endo.
I said rusting.
Thermic, is that what you're saying? So heat is either gets hot or it gets cold. Change in temperature. Yeah? Heat given off, yeah? Okay. Well, that's not altogether true. A chemical change, I know what you want to say. In other words, if the change is difficult to reverse. Well, that's not altogether true because you have equilibrium equations. In other words, if I take ammonia and I add it to water, I produce ammonium hydroxide. Okay, for instance, I'll take ammonia plus water yields ammonium hydroxide. Now, this reaction is very reversible, and it's very easy to reverse. Ammonia is a gas. You have used, anybody clean windows before? Okay, people clean windows mainly with a dilute solution of ammonium hydroxide. You can take ammonia, which is a gas at room temperature, and you mix it with water and you produce ammonia water, ammonium hydroxide, and it's very reversible. Very reversible. So, yeah, if I take water and I apply electrolysis and I change it to hydrogen and oxygen, it's hard to put it back together. Yeah, agreed. Is it, in other words, did it evaporate or what? Well, what you have to do is this: you have to check to see if whatever was created does it have a change in physical properties. Okay, so you can have a change.
So is corrosion also a change?
Change in intensive physical properties. Is corrosion chemical or physical?
Chemical.
Yeah, very chemical.
Cooking.
You're taking iron and you're producing iron oxide. Very chemical. Very chemical. That rust is not iron, it's iron oxide. All right, what else? What's another one?
Sometimes.
What is it?
Order formation.
I can't hear you.
Odor formation.
The bond of alcohol.
Smell formation. Odor formation.
Odor formation?
That's what she said.
Yeah, I'll buy that. I kind of like that actually. Odor formation. I never heard that before, but that is actually one. I mean, you're taking off a gas, but sometimes that gas is difficult to detect. Well, if it smells, if it's stinky, then you probably produced a gas, which is bubbling. Okay, maybe you didn't see bubbling, but it gave off gas anyway. Okay, maybe you had. Okay, maybe there's a chemical change. What else? Anybody? Anything else? What is it? I can't hear you.
Solubility.
Solubility? No, solubility is not one. Solubility You mean you change the solubility of the item that you produce? Well, that's changing intensive physical properties. But I'll tell you what a really good one is. When you produce a precipitate. Produce precipitate. When you produce precipitate. What's that mean? Anybody know what that means?
So water vapor.
If I take lead nitrate, and I'm going to try to do this one. I actually asked for this these chemicals, plus sodium iodide. Yes, and I produce sodium nitrate. Yes, plus what? Anybody know? Did I do this on the board before?
No, sir.
Plus PVC.
And you got to balance it.
Sir, what's a PVC?
Yeah. This is lead 2 nitrate plus sodium iodide yields sodium nitrate plus lead 2 iodide. Yes? Yes? And this is what we call aqueous, meaning it's a water solution. This is aqueous, that's a water solution. This is aqueous, that's a water solution. And this is a solid. And what you do is, to denote that it's a precipitate, you go like this. Now, this reaction is it's kind of cool. When you mix these two chemicals together, you get this incredibly intense yellow-orange color. And it's a powder that is actually a precipitate. And if you let that sit for a day, the water turns clear. And it's simply a salt solution. You can't see the salt's dissolved. And at the bottom of the beaker is this precipitate of lead 2 iodide. So you have two indications of chemical change here. You have a color change, very obvious. It's not subtle in the slightest. And it is actually, the color change is actually a precipitate. So, the production of precipitate. So what did we have? We have color change, precipitate, bubbling, heat transfer, something gets smelly, formation of odor,
Corrosion.
and what?
Oxidation.
Now, corrosion is a physical
It
property.
is also that.
Yeah, I understand that, but I'm trying to review the 5.
Oxidation.
What is it?
Oxidation.
Oxidation.
Yes, I understand that, but can we please review the 5? I'm asking, no. Those are not correct. What I'm asking for indications that a chemical change took place. So, bubbling, color change,
Okay.
heat transfer, it was either given off or absorbed, formation of a precipitate. There were 6 on the board. Formation of an odor. What was the other one? Did you write it down, somebody?
Intensive
No one wrote it down?
change in the intensive properties.
Yes, thank you, very good. That's what it was. A change in the intensive physical properties of the substance formed. What is it? I can't hear you.
Changing color.
Yeah, change in color. So that's about it. So, good luck. Have a good one. Oop, I broke your phone. You're kidding.